Hello everyone, welcome back to our YouTube channel. I am Shilpa and today I am super excited to present our project. Advanced Model Ensemble Technique for Improved Accuracy, Combining Machine Learning Models for Better Prediction. This project was done under IBM at Roman Technologies and our goal is to improve machine learning model accuracy through ensemble techniques. I am here with my amazing team Sneha R, Nagesh US and Sabita Das, and together we have worked on this existing machine learning project. Our project Advanced Model Ensemble Techniques for Improved Accuracy focuses on improving prediction accuracy in medical diagnosis by leveraging multiple machine learning models together through ensemble learning. Early detection of disease like breast cancer is crucial for effective treatment. Traditional machine learning models work well, but ensemble learning helps us combine multiple models to achieve higher accuracy and reliability. We are using a breast cancer dataset that contains medical diagnostic data, applying data pre-processing technique to clean and transform the data. Training multiple models like random forest, gradient boosting, SVM, decision tree and logistic regression. Finally, we combine them using a voting classifier to improve the overall prediction accuracy. Here, the step 1 is, first we import all the necessary Python libraries for data processing, model training and evaluation in our project. Here we are using pandas, numpy, matplotlib, pyplot, sklearn model selection, train, test, split, all this stuff. So here what is the pandas exactly tell us is used for loading and handling our breast cancer dataset. Numpy helps in numerical operations and efficient data processing. Matplotlib.pyplot used for visualizing data. Here the test train splitting. This will splits our data set into testing and training data sets. And the next one is very important one is label encoder and standard scaler. Label encoder converts categorical labels like malignant and benign. They are in the categorical labels, so it will convert into numerical values as zeros and one. Standard scaler standardized features for better prediction. Scalar ensemble random forest classifier, gradient boosting classifier, voting classifier. This is used for ensemble learning techniques is our project in our project. Scalar linear model logistic regression, simple models such as classification that we called as, and another one is decision tree classifier. The decision tree classifier, this is also one of the model we are training, and SVM is a powerful classification model called support vector machine. These are all the which are the things we should import the libraries before starting the project. Now here the first step we are going through, that is, now we'll load the dataset in our into our project. The breast cancer dataset is loaded using pd.read CSV. This pd.read CSV will read the dataset which is in the form of CSV. I'll show the dataset here. These are dataset. You can see here we have so many of columns and rows. It is ID of the patient, and if we have a diagnosis M and B, we have given malignant and benign. The malignant means is a cancerous data, cancerous, maybe that person have a cancer, and B is benign, the person have non-cancerous. And this is where we have so much inputs. Diagnosis we have M and B. By using label encoder, we will convert this categorical values into numerical values, and we have so many inputs like radius, texture, perimeter, area and smoothness, all this. This is our data set. I'll come back to my coding part. This is how I'll come back to our coding part. This is how I will put my data set into this data. Again, I'm printing the data of a project. I'm just giving shift and enter. So you can see this is my data set, columns, and this is my data set. We have 569 rows and 32 columns in our project. Next we are moving to the second step. Here in our data set we have an ID column which is not useful for prediction, so we are removing it. The ID column is just an identifier, does not contribute to prediction. We use drop ID and axis equal to 1. You can see here drop of ID in axis equal to 1. Okay, you can see here data drop ID axis equal to 1. I already told this data set, in this data set ID column which is not useful for prediction. We are prediction the person having a cancerous or non-cancerous. So for that ID is really not, we are not using that. So we are taking off that, we are removing that. So for removing, I am showing data drop of ID column I am removing. Why I am giving this axis equal to 1 means, axis equal to 1 means that column it will remove. If I give axis equal to 0, then it will remove the row. So I am giving axis equal to 1. The next one is data cleaned the diagnosis. We are using for that label encoder. When I give the label encoder, I already told in the diagnosis we have M and B, malignant and benign. These are the cancer and cancerous. It will mean. So by using the label encoder, we are converting categorical we are converting categorical numbers into a numerical numbers. So we are using this. You can see here malignant 1 and benign 0. By alphabetical order it will take. B is the first, so it is taking as 0, and M is after B, so it's taking as a 1. Next, we'll go to the main part of this project. That's our fifth step, I guess. We'll go to the splitting features of target variables. We separate input feature X from the target variable Y. X includes all the feature expect diagnosis. Y is the target column, which is 1 for malignant and 0 for benign. We split the data into 80% training and 20% testing. Satisfy y equal to, it ensures that both classes malignant and benign are evenly distributed in the train and test sets. And also the random 42 ensures reproducibility, meaning the split remains the same every time. Next, we already discussed the standard scaler. This standard scaler normalizes the data, making training more efficient, so that we are using that. So far, we have covered data loading, pre-processing, feature selection, train test splitting, and feature scaling of our project. Advanced model ensemble technique for the improved accuracy. Now, my teammate Sneha will continue explaining the next steps, where the trained different machines learning models evaluate their performance.
I am Sneha R. The data pre-processing, feature selection and train test splitting has done above. It's time to train our machine learning models and evaluate their performance. In this project, we focus on advanced model ensemble techniques for improved accuracy, where we combine multiple machine learning models to enhance prediction accuracy. Before using ensemble learning, we first train individual models and analyze their performance. Now we start by initializing 5 different machine learning models. Each model has a unique way of making predictions, which will later contribute to ensemble model. The models used are logistic regression, decision tree classifier, random forest classifier, gradient boosting classifier, and support vector machine SVM. In logistic regression, it is a simple yet effective linear model for classification of tasks. In decision tree classifier, the tree-based model that splits data based on feature importance. In random forest classifier, an ensemble of multiple decision trees to improve prediction accuracy. In gradient boosting classifier, a boosting algorithm that corrects weak predictions step by step. In SVM, a model that finds the best boundary to separate different classes. To ensure that results remain the same across multiple runs, we set a fixed random state value. This makes our experiments reproducible and ensures consistent model behavior. In storing models for efficient execution, instead of training each model separately in different code blocks, we store them in a structured way. A dictionary is used where each key represents the model name and its value holds the corresponding initialized classifier. This allows us to iterate through models efficiently, reducing redundancy in our code. Training and evaluating models. In this, each model is trained using training dataset, where they learn patterns in the data. Once trained, they are tested unseen data to check how well they can predict outcomes. We measure their performance using two key metrics. One is accuracy score and another one is ROC AUC score. In accuracy score, this tells us the percentage of correct predictions made by the model. In ROC AUC score, this evaluates how well the model distinguishes between malignant and benign tumor. To compute the ROC and AUC score, we use the model's probability prediction. This function, predict underscore proba, provides probabilities of each classes of both classes, and we extract the probability of class 1 for better evaluation. Storing results for comparison. Once the models are evaluated, we store their accuracy and ROC AUC scores in structured format. This helps in comparing different models and selecting the best one among the performances. This helps in comparing different models and selecting the best one based on their performances. Now that we have trained individual models and evaluated their performance, the next step is to combine them using a ensemble learning. My teammate Nagesh will gonna explain how we use the voting classifier to improve our final prediction accuracy.
I'm Nagesh US. We train different machine learning models like logistic regression, decision tree, random forest, gradient boosting (SVM) to predict whether a tumor is benign or malignant. Instead of choosing just one model, we used an ensemble model to combine their predictions and improve accuracy. The voting classifier takes all these models and averages their prediction probabilities. Soft voting making the final decision more reliable. We then trained this model using fit of x train, y train, made predictions using predict of x test, and measured accuracy using accuracy score of and ROC AUC score of. To compare all models, we stored the accuracy and ROC AUC scores in a pandas data frame and plotted them using matplotlib. Now I'll run my code and I'll show the bar chart. The x-axis represents the different models while the y-axis shows their performance scores. The purple bars indicates accuracy and the yellow bar shows the ROC AUC score. From the chart, we see that the ensemble model performs the best, as it combines multiple models for a more balanced and accurate prediction. While decision tree had a slightly lower performance, random forest and gradient boosting performed well. The ensemble method helped achieve higher stability and accuracy, making it the best choice for a real-world cancer prediction. Now my teammate Sabita Das will continue explaining the next steps.
Hello everyone, this is Sabita. In this part of the project, we evaluate the performance of our assembled model. We take user input for prediction and display the final result in an intuitive format. We start by generating a classification report using classification report y-test y-pred assemble. Target names as benign, malignant. This report provides essential metrics such as prediction, precision recall, and F1 score for both classes benign, non-cancerous, and malignant, cancerous. The classification report helps us understand how well our model is distinguishing between two categories. Additionally, we print a performance summary that includes the model overall accuracy, the ROC score. The accuracy score represents the percentage of correctly classified instances, while the ROC score measures how well the model differentiates between benign and malignant tumor. A high ROC score, typically above 0.95, indicates a reliable predictive model. Next, we implement an interactive system where user can input their own feature values to get a cancer prediction. To get user input, function prompt the user to enter values for each features in the dataset, storing them in a NumPy array. Since our model was trained on standardized data, we must scale the user input using the same standard scalar transformation applied during training. So this ensures consistency in feature scaling, preventing misclassification due to differing value ranges. The scaled input is then passed to our trained voting classifier Ensemble model for prediction. The model output whether the tumor is benign or malignant along with a probability score that represents the confidence level of malignancy prediction. If the prediction is 1, it indicates a malignant tumor. If 0, it suggests a benign tumor. So now we look upon the code and we run the code and we get the predicted result. So firstly we get the classification report for Ensemble model, that is precision, recall, F1 score and support for benign and malignant, and accuracy, macro average and weighted average. So the values are displayed on the screen. Next we check the performance summary, that is Ensemble model accuracy, that is 97.37%, and Ensemble model ROC score, that is 0.9983. Now we enter the values for following textures. Firstly, we give the radius mean, texture mean, perimeter mean and area mean. All the values are given and then we check the predicted result. In the predicted result, we get the predicted diagnosis, that is the output is malignant, that is cancerous, and then we get the confidence score of malignancy probability of 0.9859. So now I conclude the video. We summarize our work by reiterating that Ensemble learning significantly improves prediction accuracy compared to individual models. By leveraging techniques like soft voting, we have created a robust and reliable cancer prediction system. However, further improvements can be made by incorporating cross-validation, hyperparameter tuning, and even deep learning techniques to enhance predictive performance. The project highlights how AI and machine learning can aid in healthcare diagnostic, helping doctors and researchers make better informed decisions. So, I hope you found this video helpful in understanding how Ensemble learning improves prediction accuracy. Thank you.